Hey guys, this is going to be an introduction on the life cycle of software and how to effectively make use of it. I'm going to be using Enterprise Architect just to explain a few things, just to visualize it on the screen, but essentially most software will go through 4 key stages. So if I just use classes for this, bit easier to manage. So the first one is the requirements. So requirements are what your software needs to do. They are a description, typically a textual description of all the elements that your software needs to be capable of in order to be for you to say that it's done. They're typically split between functional and non-functional. So functional requirements are things like, I don't know, in terms of game design, it'd be like the player can equip items or something. And non-functional requirements are typically things like the game should be able to run an average of 100 to 120 FPS on this system setup, or something to that effect. And then this usually goes to this goes to design. So the design stage of a life cycle will be where you take what you have in your requirements and you start to produce, let me think about this, probably you start to figure out what aspects of your system there are, what they have, and what they need to be able to do. So an example of this, if you had some kind of statement in your requirements, so let me just give you one of these as note. There we go. So if you had something like, well, let's use the other example, to equip. Alright, something as simple as that, right? So we've got the player is able to equip items. Then you would probably end up with, there's a player. So there's a player, an object or a class of player. And then there's a object of item. And the player has the ability to equip the item. So this would have an association to item, and the player, oh, hang on, I seem to have lost my features operations. Sorry, right. Yeah, that's right. Something like that. I don't know why I put a space in there, but you get the idea. Right. So from just this requirement, we can know that there's a player object, an item object, and the player has a method of equipping an item. So that's what the design stage will encompass. And then when you go to more detail, you start expanding these, and you could have things like, what you could assume from this, if the player is able to equip items, therefore they're able to store them on their person. I believe it's this and this, and then you could say this will be a property called equipped items, and I could say it's of type item. And I believe I could even container type array. Well, this would actually be a. And there you go. So we've got, very quickly, from a simple textual description, this is just a quick example of how you go from a requirement to some basis of design. And so this is what things need to have, what they need to do, and then after design you go straight into implementation. Without N. There we go. Let me just zoom in a bit here. Cool, right. So implementation is just that. You implement the code. So once you've done your design, you'll have loads of attributes and operations and objects, and they may not necessarily be the way you would actually implement them. So the player, for example, particularly in the Unreal Engine, is actually implemented in a similar way to this, but it's split into two core classes. So what you actually have is the player character and the player controller. Okay, so the player controller actually has the equip item, and the player character has the equipped items. And the reason for this is because then you can have different ways of controlling the character, and the character just has the things rather than does the things, if that makes sense. So the character is just a container of information, and the controller is how to manipulate the information. So the implementation may not mirror exactly the design, but it should have what you put in the design as a bare minimum. And so it's a bit hard to work out. In a lot of cases, you'll do something which seems very simple on this level. It's like, that's fine, player with items. And then you come to actually implement it, and you find that it's almost, in some cases, it may even be impossible to do it the way that you've designed it, because the game engine you're using isn't capable of it, or it already has a way of doing something, but you hadn't accounted for it, and so on. So that's more with experience, but later on I'll talk more in depth about each of these stages. But there's aspects to design where you would figure those things out before you go too far into making your game. You tend to do proof of concepts with the technology you have available before you design the entire thing. The requirements are usually fine. You know you want to do all of these things, but you may not know how to do them. But the advantage, of course, is that if your requirements almost never change, then you can know that the design, once you've kind of done something, designed it, that will be less likely to change. The code is the bit that's a lot more volatile. But then we come on to the last part, which is, of course, testing. So I'll just and testing, I mean, there's not really much to say about this. There's a lot of approaches to this, but typically what you end up doing is you test the requirements. So if I do this, and I think it's that, something to this effect, right? So you test each individual requirement. The idea is you're proving that your software, which is, well, this bit, actually conforms to this. So if you can't find an operation or a sequence diagram or something that explains your requirements and actually satisfies them, then you've probably done something wrong, and you need to go and revisit the requirements and design the code. And that's the point of it. A lot of people consider testing to be like, if the tests have all passed, it's good to go. And in most cases, that's true. But the reason you write tests is to find problems. It's actually good when it finds problems, because you catch them here before it goes off to the actual end user afterwards. So if you ever design something and you forget to implement requirements and things, it happens, and you usually pick them up here. So yeah, that's the fundamentals of a typical life cycle for software. This is actually called a waterfall life cycle. I believe there's others which I cannot for the life of me remember what they're called. But a lot of software and hardware will go through this process limited amount of times. A lot of large projects that are very dependent on things being done correctly the first time would get all of their requirements, all of their design, all of the implementation, all of the testing done in each stage before moving on to the next. But in modern software, it's much more common that you'd get some of the requirements, some of the design, some of the implementation, some of the test to make proof of concept projects, just to prove that you can do the bare minimum that your application should be capable of. So when you're doing this for game development, you would say, okay, I just want a game where the player can run around and shoot things, and maybe there's items that they can have in an inventory or something. And so you set up those requirements. There'd probably only be like a 50, 60 of them or something. You design them, implement them, test them. And then once you've got that, you can then add more requirements and refine the existing ones, and then improve the design, improve the code, and so on and so forth. And it allows you to get something in place that you wouldn't perhaps have had if you'd done everything at once. The advantage of that, of course, is to do things quickly. The disadvantage is it's easy to miss things, and anything you don't do correctly at the first stage can make all of the other sections a bit harder to work with, but that's what happens. You'll find most people just do this, or well, just the implementation and nothing else. Some people don't even do requirements, which is concerning. But I'll talk a bit more about that later. But this is the one I'm going to be focusing on, the standard approach. But you can kind of hopefully pick and choose between the videos that I do to figure out the ones that actually matter to you, I suppose. But yeah, thanks for listening, and hopefully I'll carry on and sort out the rest of them. So, cheers.